Okay, hello. We've got another satellite moving around the Earth problem. Hopefully by now you can see this is like, oh, I should set up some centripetal motion type situation, and that's the right thing to do. So what's keeping this satellite in orbit is centripetal force. Ooh, need to add notes. Okay, centripetal force. What's causing the centripetal force in this situation is gravity. So the centripetal force equals the gravitational force. All right, the centripetal force is mv squared over r, and the gravitational force is big G m1 m2 over r squared. There you go. We can cancel some stuff out. So centripetal force, that's like the force on the thing that's orbiting. So that's the force of the satellite. Okay, the mass of the satellite. And the mass of the satellite is up over here. Is it m1? Is it m2? It doesn't matter. Those are just labels. They mean like the mass of the first thing and the mass of the second thing. So the one that's left is the mass of the Earth. So we actually don't need the mass of that satellite. It cancels out. So that's handy. We're asking for the speed. So let's tidy this up. Let's move that r over. So big G times the mass. To get rid of this r, instead of dividing by it, we're going to multiply by it. So r is going to go over there. These r's stay here. To undo that squaring, we're going to square root. We have r up here. That'll cancel out with one of these r's down here. And so to find the velocity, we need to know big G, which we do. That's a constant. It's on your formula sheet. We need to know the mass of the Earth, which they gave us right here. Maybe by now you've memorized it because you use it in a lot of these problems, but if you haven't memorized it, that's okay. And we need the radius of this satellite's journey. That's what we don't have. But once we have it, we can calculate the speed. All right, so to calculate that radius, I'm going to move my face. Whoa. Every time. I will do that every time. Okay, so we need r. Okay, so let's think about this. What information have they given us that we've not used yet? The radius of the Earth, which is, I guess, handy, but we don't need it. The r down here, that's the radius between the objects. So we have like satellite and Earth. So when stuff's like on or near the surface of the planet Earth, the radius of the Earth is basically the distance between them. But since we're talking about something that's like in space, the radius of the Earth is like part of the distance, but it's not the whole distance. It's definitely not like most of the distance. So we won't end up using that number. We don't need that. Let's see. We want the radius. We have the time period, and y'all have a handy formula for relating those. I've never seen this formula before in my life, but I figured out how to use it. So it's T equals, I'm going to get this wrong. Okay, y'all just like bear with me. It's gonna like probably flash some stuff in front of you. Where's the formula sheet? I'm so sorry if this is making you dizzy, all the scrolling. I have no short-term memory. Just a second. I'm so sorry. If I could edit this out, I would, but I don't know how to do that. Okay, so that's our formula. Can I just put it here? That'd be nice. No, I'm not that fancy. Okay, so 2 pi r to the, what? 2 pi r to the 3 halves over, what? Root G ME. Okay. Like I said, I'd never seen this formula before in my life. Sorry if you've ever taught me physics and we use this formula, I forgot it. But I did not forget how to problem solve. So we can use this formula. So we have T, we have G, we have ME, and we're looking for the radius of this satellite's journey. So that'll be one equation, one unknown. We can do this. First of all, the time period is in minutes. We need that in seconds. So if you've taken chemistry and are good at dimensional analysis, you can do that. Otherwise, you just gotta like logic through. So 90 minutes over 1 times 1 minute. Each has 60 seconds. If you multiply that, 9 times 6 is 54. Add both the zeros, 5,400 seconds. So 5,400 equals 2 pi r 3 halves over root G ME. We have numbers for those. R 3 halves, root. So G is still 6.67 times 10 to the negative 11, and ME is still 5.97 times 10 to the 24. One equation, one unknown. Let's do this. So 6.67 e to the negative 11 times 5.97 e to the 24. Take the root, multiply by 5400, divide by 2, divide by pi. Okay, so then we get down to this nonsense. We get 1.7 times 10 to the 10th equals r to the 3 halves. Okay, I had to Google this too, because like r to the 3 halves, what is that? But this means, so like that's the same as r to the 3rd. It's the Q, so r to the 3rd stays r to the 3rd. We're going to keep that in here because that's a whole number, that's on top. R to the 1/2 means square root of r. So we stick the little 2 over here. So square root of r cubed. So 1.7 times 10 to the 10th equals the square root of r cubed. So to unsquare root something, you square it. So this thing, it should still be in your calculator. Make sure you're not like over rounding. So square my answer. Cool. So I got like 2.9 times 10 to the 20th equals, now we're at r cubed. So now we need to get rid of that cubed. So the way we do that is we take the cubed root. I don't know how to punch that into this calculator, so I just do to the 1/3. That's the same thing. So I'm going to go to the little like thing, to the, and then I'm going to open parentheses and do 1 divided by 3. Close my parentheses. I get this like 6,000 number. So 6650321.625. 1, 2, 3. If you did scientific notation, it's like 6.7 times 10 to the 6. Yeah. Ew. I don't know what that is. So I'm going to store that as x, so I don't have to like worry about losing a decimal. But anyway, that's our r. So now we can plug this in right here where this r is. Okay. So big G is still 6.67 e to the negative 11. Multiply that by the mass of the Earth, which is 5.97 e to the 24th. Divide that by that r. I stored it in my calculator as x, so I can just bust out that x. And then be sure to take your square root. All right, and I got 7738 meters per second, which is E. Okay, so there's a lot of like mathy wrong turns to take there. Be sure you're converting from minutes to seconds correctly. Be sure you like learn how to do this R thing with like to the 3 halves. That takes some practice. Be sure you don't do it backwards and do like the cubed root of r squared. That's what I did the first couple times, and I was like, why am I getting it wrong? That's why I was getting it wrong. What else is tricky? There's exponents and scientific notation. So if you are not typing in your calculator using this E button where the comma is, you see that EE? That is the fast way to type numbers in scientific notation. It is worth taking a second and learning how to do that, especially if you're an engineering major or any science major really. If you're going to be taking these kinds of classes where numbers get really big or really little, it's worth now taking a moment to Google like scientific notation or like exponent notation, TI 84 plus, or whatever your calculator is. That's worth looking at. I'm not going to make a video on how to do that because I'm sure lots of them exist. All right, that's number 7.